Okay, a basketball player shoots a ball from behind the three-point line, 7.5 meters from the basket. So we want to know how fast he's got to shoot the ball in order to get it in the basket if he shoots it at 60 degrees above the horizontal. And we're assuming it was released from the same height that it was launched. Just a warning, this one's going to be a little bit long and a little mathy. So what do? First, I put all my stuff into my X and Y columns. So in the X, I know my D is 7.5 because that's how far he is away. In the Y, I know the D is 0 because it's shot from the same height that the basket is, and acceleration is negative 9.8. I have the drawing there with my right triangle. Please be aware that just because this one's going to take up a little bit of space, I'm not writing out that V in the X is cosine of 60 degrees times V because it's the adjacent side, and V in the Y is the opposite side, so that's sine of 60 times V. So in the X direction, we only have one equation, which is that the distance in the X direction equals velocity multiplied by time. And that velocity is obviously the velocity in the X direction. In the Y direction, we would want the equation that does not have VF in it, so that would be D equals V naught T plus 1/2 AT squared. What I'm going to do is I'm going to plug in where I have Vx and where I have V naught, what I have listed in the red and green columns for that, which is the cosine of 60 or the sine of 60 times the actual V. It's because this is what's going to ultimately happen. We don't know what the actual velocity is, so we're dealing with unknowns on both sides. So on the left side here, the distance in the X direction is going to equal the cosine of 60 degrees times the velocity multiplied by the time. In the Y direction, D equals the sine of 60 degrees multiplied by the velocity multiplied by time plus 1/2 AT squared. All right, from here, what I'm going to do is on the left side with D, because ultimately what we got is we've got a simultaneous equation where we don't know the velocity, which is in blue, and we don't know the time. But we know the time is something that everything in projectile motion shares. So the T, whether it's red or green, is the same thing. So on the left side, I'm going to rearrange that equation slightly to get time all by itself. And what I get is the D over the cosine of 60 degrees times the velocity is equal to time. And what I'm going to do with that bit of information is I'm going to plug it in my Y equation everywhere I see a T. This is going to start making this a fairly large equation, but we'll try and fit it in as best we can. Not sure where that came from. All right, let's power on. So in the Y direction, what happens to my equation now? I have D equals the sine of 60 degrees times V. But now instead of T, I have D divided by cosine of 60V. And what that looks like is D. And all that divided by cosine 60 stuff can go right down here. Cosine of 60 degrees V. Now I've got my other term, which was the 1/2 AT squared. So what that turns into is the 1/2 and the A. But now I've got to put in my D over cosine 60 degrees V into where T squared is. I've got to make sure I square everything. So in the top, that gets me D squared. And in the bottom, what I get is cosine. That should be a squared there. Sorry, it's a little tough to see. Of 60 degrees on V squared. So that's what that looks like. It looks a little messy, but we're going to clean it up. So the first thing we're going to do over here on the first term of the sine 60V D over cosine 60V is I have V divided by V, so I can cancel those out, making my life a little bit easier. And if you remember back from your old trig functions, maybe you remember those, maybe you don't, sine of 60 over cosine of 60 turns into tangent of 60 degrees. Cleans this up a little bit for this first term. Unfortunately, this right term is going to remain a little bit ugly looking, at least for now. So I'm going to keep right now as is 1/2 a d squared all over the cosine squared 60 degrees d squared. Okay, so now what I'm going to do is I'm going to get this tangent 60 degrees times d over to the left side. I'm going to isolate that really ugly term that we are going to deal with in just a minute. So I get d minus the tangent of 60 degrees multiplied by that distance in the x. That's going to equal my 1/2 acceleration d in the x squared divided by the cosine squared of 60 degrees times v squared. All right, now what we're going to do is we're actually going to plug some numbers in and make our life a little bit easier. It's not going to look quite so ugly. And when I plug in my 1/2 times a, which is negative 9.8, and I have d, which is 7.5, and I square it, is going to make it so I have a number there. It's not going to look quite so ugly, and it'll be a little bit easier for us to rearrange. So I'm going to rewrite my equation. And I still have d on the left side, minus the tangent of 60 degrees. And that's still multiplied by the d in the x direction. And that's going to equal, as I said, if we multiply the 1/2, and we multiply the a, and we multiply that d, so it's 1/2 times negative 9.8 times 7.5 squared. And what I get is negative 275.6. And if you want the units on that, it's a little bit weird. It's actually meters cubed per second squared. And that's all still divided by, keep our color scheme the same, that's all still divided by, in red, the cosine squared of 60 degrees multiplied by b squared. Now we're going to simplify this just a little bit more. On the left side, I've still got d. I've still got it subtracting tangent of 60 degrees times that distance in the x direction. You might have wanted to plug in your numbers a while. You can if you want to. On my right side, if I take negative 275.6 and I divide it by the cosine of 60 degrees after that's squared, what I'm going to end up with over in my right side is negative 1,102.4, and that's still meters cubed per second squared. And that is all over v squared. All right, it's cleaned up a little bit. It's not too bad looking. Now what I've got to do is I've got to rearrange this for v squared. So I'm going to multiply v squared over to the left side, and then I would divide out this term right here. So I'm going to multiply this guy up right there and divide by the stuff that's in my fraction. And what that's going to look like is v squared equals that negative 1,102.4 meters cubed per second squared. That's all divided by, and if you want at this point in time, you can plug in the numbers if you like. The d in the y direction is just 0. Probably could have just gotten rid of that a while ago, but we didn't. Times the tangent of 60 degrees multiplied by the d in the x direction, which is 7.5 meters. Well, we don't want v squared, we just want v. And in the sake of not having to rewrite this yet again and make this take a little bit longer, we know if you want to get rid of a squared for the v, we do the square root of everything under there. So once I plug all that into my calculator, I should get that the velocity is 9.2 meters per second, which is how fast this guy's got to throw this ball in order to get it to go into the hoop 7.5 meters away. I know it's a lot of work and it looks really ugly, but it is what it is. So we are done.